This is the code writing exercises for Nitro 5.7, and in 5.7.5 they want us to write a randomizer class. So first we have to return a random number from 1 to 10. So we're going to use the math.random method, and the usual syntax for doing this is to multiply. So the math.random gives you a random number between 0 and 1. And if you multiply that times your range of numbers plus 1. So I'm going to format it like this. Our maximum number is 10 minus our minimum number, which is 1, plus 1. That's the general format. And so we're basically multiplying by 10. So that gives us a random number from 0 to 10, but not including 10. So we'll never get that 10. So then if we take that whole quantity and we add 1 to it, now we'll have a random number between 1 and 11, but not including 11. So from 1.0 all the way up to 10.99999, and then that entire quantity we cast as an int, and then that'll chop things off to 1 through 10. So we want to do that on that one, and then almost the exact same thing on this one, but this time our max is specified and our min is specified, and this is also our min. So that's the syntax for doing that, and we're going to cast that quantity as an int also. Then over here in our tester, we're going to print out allegedly 10 random numbers from 0 to 10 and then 10 random numbers from 5 to 10 and see if that works. So I'm going to do some more of these just to make sure we're getting ones. I see the 1, but I don't see a 10. So I want to make sure that we're getting 1s and we're getting 10s. Okay, so there's some 10s. I should never see an 11. And I should see some 1s, but I should never see a 0. Okay, so I'm happy that that's working. And then let me see some more of these. Those are supposed to be numbers from 5 to 10. So now I'm going to do 100 of them. So our numbers from 5 to 10, I should see 10, but I should never see anything bigger than 10. I should see 5, but I should never see anything less than 5. So just making sure there's nothing less than 5. I think we're okay there. Time to check that code. So that's the randomizer class. And let me just bring up a notepad because we're going to need that code. It's only one line each, but we're going to need that code in the next section. Okay, so we're ready to move on to 5.7.6, which is rock, paper, scissors. That sounds like a lot of fun, but maybe a little bit involved. So first of all, in the randomizer class, they want us to redo what we did previously for the randomizer class. So we're going to do this for a number from 1 to 10. And we're going to do this for a number from min to max. Okay, and then I think that's all we need to do in the randomizer class. Then we have a lot to do over here in rock, paper, scissors. So first you'll ask the user to pick either rock, paper, or scissors. So before we can do that, we need a scanner object. So scanner my input equals new scanner system.in, and then we're gonna supply a prompt for the user, system.out.println, and they say we should say this, so let's just copy that and say that right there. Okay, and then we're going to call this a string, and we'll give it the name user. My input equals next line. And then just to check that this is working properly so far, we're going to do system.out.println user, and then colon, and then space, and then whatever the user picked, which is stored in our variable called user. So it does not like this. String user my input. Oh my gosh, my input dot next line. Oh, that was very interesting. And then why does it not like this? Because there's no return value. Return, I have nothing to say, because we haven't implemented that yet. Okay, so my choice is rock, and it says user rock. And if my choice is Alabama, okay, then it's Alabama. All right, so far that's recording the user's choice. Then we're going to have the computer randomly choose one of these. So now we're going to do an int, and I'll call this computer index is randomizer next. What did we call that over here? Randomizer next int, and we need to supply a min and a max. So randomizer next int, and 1, 2, 3. So at this point, if we say computer, and we say computer index, this should just print out a random number for the computer. So if we choose rock, computer chooses 2. If I choose rock again, computer chooses 3. If I choose rock again, computer chooses 3. If I choose rock again, computer chooses 1. So we're getting a random choice by the computer. Then let's set up an if statement. If computer index equals 1, then let's say, well, first of all, let's create a string called computer, which is going to start off to be blank. If computer index is 1, then let's say computer equals rock. Else if computer index equals 2, then we'll call the computer variable paper. Otherwise, we'll call the computer variable skizzers. So now we have a variable or a string name for the computer. So instead of printing out the computer choice right there, I'm going to print out the computer choice right here, and it's not going to be computer index, but it's just going to be computer. So now if we run this, I'm going to do several variations here. If I choose rock, computer chooses rock. And if I choose rock again, computer chooses scissors. If I choose rock again, computer chooses paper. So it looks like we're getting random choices by the computer, which is what we want. So then the next thing is we got to figure out a way to determine the winner. So we use the randomizer class for the computer to make a choice, and then we have to print out the winner. And we should keep playing the game until the user hits enter. We'll implement that at the very end. You'll need to implement a method called string get winner. So they already have that up here that determines whether or not the user or computer won the game and return the correct answer. So there's a lot of ways of doing this. What I would like to do first is set up a long if statement that will determine if there's a tie. So just simply the word tie. So if we say if user equals, okay, now I would love to say this, but I can't, but just bear with me. If user equals computer, then we should return the word tie. So whenever they both choose rock, or they both choose paper, or they both choose scissors, then that should be a tie. Otherwise, I have nothing to say. But remember, we can't use this double equal sign when comparing strings, so we have to do user dot equals computer. Whoops. User dot equals computer. And then there's one other thing that I want to change. I called my variables down here user and computer, and they're also being called user and computer up here. So I think I'm going to change this to just be the letter U, and I'm going to change this to just be the letter C. So that way I'll keep straight what variable is what in what method. So then down here we can say system.out.println, and then we're printing the result of get winner. We're printing the result of get winner. But the get winner method, we have to supply it what the user chose and what the computer chose. So this should work partially. It should work in the case of a tie. Oh, what is the problem here? Oh, I got the word user and I changed it to U. Let's fix that like that. Okay, so I choose rock, and look, the computer chose rock, and we have a tie. Very nice. Okay, I choose rock. That was boring. I choose rock. This is very boring. I choose rock. The computer chooses paper, and we haven't yet taught it what to do in that case. So now I want another if statement here. Well, not really an if statement, but an else to the previous if. I want to write a very elaborate conditional right here. This is like the crux of the whole thing. I want to write a very elaborate if condition that will determine when the user is the winner. Okay, so something goes here to determine if user is winner. And if that happens, then I will return user. And if it's not a tie, and if the user isn't the winner, then the winner will be the computer. So there's three ways that the winner can be the user. So if the user dot equals, so let's think about the three things the user could pick. User dot equals rock and something, or user dot equals paper and something, or user dot equals scissors and something. So if the user is rock, the way the user wins is rock smashes scissors. So the user will be the winner if the user has chosen rock and computer has chosen scissors. So there's one conditional, or there's one piece of the conditional. The user equals rock and the computer equals scissors. Rock smashes scissors, so therefore the user wins. Or there's other ways the user can win, but we're going to have all of them be this kind of format. The user can win if the user dot equals paper and the computer dot equals rock. Paper covers rock. And the other way the user can win, if the user dot equals scissors and the computer dot equals paper, because scissors cut paper. So if any of those parts of the OR happen, then the user is the winner. Otherwise, the computer is the winner. So I think that's what I want that to look like, but let's just double check over here. Oh, what does it say? What does it say? Unreachable statement. So I don't need to have this line here anymore. That was, remember that line I just threw in so I could get the code running. So I choose rock, computer chooses rock, that's a tie. I choose rock, computer chooses scissor, rock smashes scissors, so the user wins. Woohoo! I choose rock, tie again. I choose rock, tie again. Okay, so that I don't have to keep hitting the run button, let's implement the enter. So down here where we ask the user to enter their choice, we want to say, this is a little bit inefficient, but we want to say something like this. While user dot equals not the empty string, so I want the not in front of that. So if they enter nothing, then I want this to be done. So while they don't enter nothing, I want to run all of this code here. Now we got a little bit of an issue, but that's okay. So I'm going to go here, and then I've got to highlight all of that and move it all over one notch like that. So while the user not equals empty string, then we do this. We print out what the user chose, and then we do the randomizer, blah, 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 blah. Now, the only glitch with this is at the very end of this, we have to have the same two statements that we had up here. Let me double check that we're Yeah, we're printing this every time. So we need these two same statements. This is the only thing I don't like about a while sometimes. Okay, so we ask them to enter their choice initially. We get their input. If their input is nothing, then we're done. If their input is not nothing, then we print out what they entered. We do the computer choice. We turn that into a string, and then we print out the winner. And then we ask them again, the user, to enter their choice, and we get their input. And again, if their input is empty, then we're done. If their input is not empty, then we continue. So hopefully this will run until I'm ready for it to be done. String, okay, so I don't have to redefine string because I already defined user up here, so I don't have to redefine it down here. Okay, my choice is rock, computer scissors, user wins. My choice is rock, computer scissors, user wins. My choice is rock, computer scissors, user wins. This is kind of boring. My choice is rock, computer scissors, user wins. I'm starting to doubt the randomness of CodeHS. Or maybe it's my randomizer routine. I choose rock, computer scissors, user wins. Interesting. I choose rock, computer scissors. This is getting a little bit tedious. I choose rock, computer paper. Woohoo. Ooh, the computer wins because paper covers rock. I choose rock, computer chooses paper again, computer wins. I choose rock, paper, computer wins. I choose rock. Rock is a tie. I choose rock, paper, computer wins. Okay, so now I choose paper. Computer chooses rock. Paper covers rock, so user wins. I'm going to choose paper again. Computer chooses rock, so user wins again. I'm going to choose paper again. Computer is scissors. Computer wins. So I think that's all working the way we want it to work. And if I just hit enter, then we're done. So the only thing I don't like about this is that we're asking the user here for input and we're asking the user here for input. That's the only thing efficiency-wise that I don't like about it. One thing that is kind of cool is the way we set up this get winner. If the user enters something silly like Alabama, then when we check to see if user equals rock or user equals paper or user equals scissors, none of those will ever be true. So the player, the user, can never win if they enter something silly like Alabama. Now let me just make sure. Okay, so this word tie, and we're supposed to say user wins, capital U. So this tie is supposed to be capitalized, and this is supposed to be capital user wins with an exclamation. So this probably should be computer capitalized wins with an exclamation. And let me just, for jollies, put in Alabama. If I put in Alabama, then I should lose no matter what the computer chooses. Computer should win every time if I enter something that's not rock, paper, or scissors. So I think, hit enter, we're done. I think we're ready to check that code. Woohoo! That's Nitro 5.7.6 on to Nitro 5.7.7. I did not pause. Okay, so in Nitro 5.7.7, they want us to implement the player class. And they say we need to have a static variable. So public static int for the total players, and the variable should be incremented whenever a new player is constructed. So here's the constructor for player. All we're going to say in the constructor is total players plus plus. They haven't given us any instructions in what the player class should look like or what the constructor should look like. So all we know is when a new player is created, we're going to increment the total number of players. Then we should also have a public static int that is max players. And that will be initialized to 10. And then we should have a static method called public static Boolean game full, and this is just going to return if we've hit the max players. So we're going to return the result of comparing the total players. If it's greater than or equal to max players, if that's true, then the game is full. So I think that's all we need for the implementation of the player class. Okay, so to check out the player class, we can create a couple new players. Player 1 equals new player, and there's no instance variables in the player class, so we can just say new player and leave it at that. And then we should be able to print out the total players of the player class. So capitalized player class dot total players, we should be able to print that out, and we should be able to access it like that, player dot total players, because we made that variable over here public. So that's all we should have to do, and let's see what that looks like. Okay, so it printed out the number of players. By the way, if we print out the number of players at the very beginning, then it should print out 0. And if we do this a whole bunch of times, that's 3, 4, 5, 6, 7, 8, 9, 10. And actually each time I'm also going to print out player game full. So we have a game full method, and it's static, so we can call it from the player class. We don't have to call it from a player 1 object. So we're going to say player game full. And then I just don't want all of these to be player 1. So I've got a player 1 and a player 2 and a player 3 and a player 4, player 5, player 6, player 7, player 8, player 9. This is not required. I'm just doing it for fun. So now it first prints out that there's 0 players, and then when we add the first new player, there's now 1 player, and false for game full. And then we add the next player, player 2, so now there's 2 players, but again false for game full. So every time we create a new player, the total players variable is being incremented by 1, and then finally when we add the 10th player, the game full returns true. So I'm pretty sure that's all we had to do in that class there. And we are done with Nitro 5.7. Woohoo!